Oh, good day. In algebra, we are covering our first PO3, which is adding and subtracting rational numbers. That, of course, includes decimals, integers, decimals, and fractions. We learned about that in CO1. And we're going to start with integers. And this being a key point, if you need it, this table can go on a help sheet for you. You obviously will not be able to use a calculator on this section of the test because I have no desire to test whether or not you can press buttons in the correct order, but that you understand the operations and what's going on here. So we'll start filling this table out. You kind of look at what we have down below here. And even though it's addition and subtraction, which is kind of the first math operation that you learned way back in first grade, second grade, now we throw in a whole bunch of negative signs and some parentheses and things like that. So we're going to sort all of this out. Okay. So we're going to start with when you add a positive, okay? When you add a positive, give me an example of one of these 18 expressions down below that shows we're adding a positive. Yes. Negative 7 plus 9, that is adding a positive. Give me another one. What else shows we're adding a positive? Yeah. Negative 9 plus 9? Yes. That is adding a positive. Another example, yeah. Negative 15 plus 31 is adding a positive. Any others? Adding a positive example? No, I think that's about it. Okay. Now, even though all three of these start with a negative number, negative 7 plus 9, negative 9 plus 9, negative 15 plus 31, why is it adding a positive? When we say add a positive, what are we looking for? What clues us in that we're adding a positive? Let me ask it a little bit different way. Does the sign of the first number matter as far as the operation? No. Not at all. That just shows you where on the number line you're starting. What's your starting value, and then what are you doing after that? Okay. So the operation when you add a positive is addition. The direction on the number line when we add, we go to the right. And an example would be something like negative 7 plus 9, which the answer to that would be 2. Starting at negative 7, going to the right 9, and we end at positive 2. Okay? How about when we add a negative? When we add a negative, give me an example of adding a negative here in the 18 we have down below. Noah. 13 plus negative, minus negative 13. So that actually is not going to be adding a negative. Here's would be an example, one we'll get to in a little bit, subtracting a negative. Which one shows adding a negative? Yeah. 14 plus negative 3 is adding a negative. 12 plus negative 15, adding a negative. Any others? Yeah. Negative 25 plus negative 8 is adding a negative. Any others? I think those are the three. Okay. And really, what operation does this represent? When we add a negative, we're actually not adding as far as when we actually do the math. We're subtracting. Which means on the number line, we're going to the left. An example of this would be 14 plus negative 3. And the value of that is 11. Okay? Adding a negative 3 is actually subtraction. So we're going, starting at 14, we're going left 3, and we end at 11. Okay? How about when we subtract a positive? What's an example of us subtracting a positive from these 18 examples? Yes? Negative 7 minus 19 is subtracting a positive. 12 minus 20. Another one. 0 minus 4 is another one. 5 minus 3. Negative 13 minus 6. Negative 42 minus 17. There's actually quite a few on here. 14 minus 6. Okay? Those are all examples of subtracting a positive. Whether or not our first number is negative or positive, okay, that doesn't affect the operation. We see that again here. That just tells you where you start. The operation when we do this is subtraction, which is again to the left on the number line. An example would be negative 13 minus 6, which is what? Negative 19. If you're thinking negative 7, you went the wrong direction. You went 6 to the right, right? Negative 13 is where we're starting. We're going to the left 6 more. That ends at negative 19. Negative 19. And then finally, subtracting a negative. Here's an example of subtracting a negative. What's different about 13 minus negative 4 and one like negative 13 minus 6? Our example from, because these two get mixed up quite often. What's the difference? Noah? Sure. So this is the same as writing 13 plus 4, but why don't the negatives cancel out in negative 13 minus 6? I mean, they both contain 2 negative signs. Why is one addition, 13 minus negative 4? Why is the other one subtraction? Brent? Well, that subtraction sign technically makes the 6 negative. So it's not so much that. I mean, it is subtracting positive 6. I can see it based on what we've talked about there. But yes, these two negative symbols, these subtraction signs, are in between the numbers, right? They're right next to each other. What's in between the numbers is where your operation is. This negative sign out in front here just serves to tell you where you start. And then you're subtracting 6. Versus starting at positive 13 and subtracting negative 4, it's that these two signs are right next to each other that changes the operation to addition. For you linguist people, why can't you have a double negative in a sentence? Right? If you say, well, I'm not happy, well, if you're not happy, that means you are happy, right? They kind of cancel out. So when you subtract a negative, it is the operation of addition, which means we're going to the right on the number line. So something like 13 minus negative 4 is going to give us everybody or nobody or just one person. 17, yeah. Okay. Questions on that so far? Review for the most part? Good. Okay. So you've got these 18 to do here, and that is the integer section. We'll move on to decimals. Decimals. And decimals, really, what's the big key point here when adding and subtracting decimals? What's kind of the thing to keep in mind? Yes, Noah. Line them up, right? Make sure those decimal place values are aligned. 7.1 plus 12.6, you wouldn't write that like this to add it, right? Because now you're adding 7, which is in the ones place, to the 1, which is in the tens place, and that's not good. Okay? So when you line these up, oh my goodness, we get there we go. We get 7.1 and 12.6. Now we're adding the tenths with the tenths, the 1 and the 6, the 7 and the 2, the ones with the ones, and then our tens there. So that's just, I mean, you know that. I think just a brief reminder is valid. Let's talk about this third one, though. Negative 3.65 minus 14.12. Give me who said you would add it? Would you like to expand on that? Sure. So even though you say you're adding it, you're suggesting that we can take 3.65 plus 14.12. No? Okay. But you're not wrong as far as we can just add them goes. But you want to, yeah?
Add them, and then once you're done adding, just add a negative sign.
Right. You can add them together, and once you're done, just make your answer negative if you understand what's really going on here. So let's put up a number line, and you don't have to do this on your page if you don't want to, but negative 3.65 is going to be somewhere over here, okay? And this says we're starting at negative 3.65, and we're subtracting, so we're going to the left, 14.12, right? That's what's happening here. And our answer that we end up with is negative 17.77. Isn't that kind of similar to starting at positive 3.65, which is the same distance away from 0 as negative 3.65, and then adding 14.12, going 14.12 to the right? Because what number are we going to end at if we take positive 3.65 and add 14.12? 17.77. Okay? So whether we start at negative 3.65 and go further left, 14.12, or start at positive 3.65 and go further to the right, 14.12, we're still going to end up 17.77 away from 0. Of course, then, since this is what we're actually doing here, our answer is going to be negative 17.77. But when you said that you can add them, you can kind of write, as long as you then understand that you need to make your answer negative once you're all done. Okay? There are really more similarities than differences when you talk about the positive and negative side of 0. All right? Questions on that? Okay. Anything else with decimals? I think that's the only kind of one that we need to talk about there. Okay. So then we move on to fractions. Everybody's favorite thing. Okay. Tell me what we need to. Oh, brother. Tell me what we need to keep in mind when adding and subtracting fractions. You've probably heard this from every math teacher you've ever had ever in your life. Yes. You need those things called common denominators. Okay. Why is that? You ever stop to think about why? Well, yeah.
Because if they didn't have common denominators, it'd be like taking a big half and trying to add a small h to it.
Sure. The denominator of a fraction, it describes something. It describes how big the piece is, okay, in relation to the whole, right? It's almost as if they are things, 2/12 plus 7/6. Each 12th and each 6th, they aren't the same. It'd be like we were adding, 2 chairs and 7 tables. You can't put those together. What are you going to get? 9 chables? Doesn't make any sense. Okay? If you were a zookeeper, I bring this example up because my son, who is 4, he wants to be a zookeeper when he grows up. And his definition of growing up is being 7 when he can ride his bike to his zoo and be a zookeeper. So we'll see what happens with that. I mean, I don't want to crush his dreams or anything, but okay. But anyway, if you were a zookeeper, you would not take 2 pandas and put them with 7 lions. That wouldn't end well. Okay? Things need to be the same to combine them. All right? So we need to make the denominators the same. And the way this is written, actually, we can do it 2 different ways. We can either take this 2/12 and simplify it to be a 6th, or we can take the 7/6 and we can make that 6 into a 12. What are you feeling like doing? What would you rather do? Yeah, in the back. Go to 12s? Okay, so we're going to keep our 2/12 the way it is here, and we're going to multiply both 7 and 6 by 2 to get 14/12. and we're going to add them now with those common denominators. Okay? Now that we've done that, what's the second rule for adding and subtracting fractions involving those denominators? They have to be the same, and Audrey, they have to stay the same. Okay? If you are adding 2 lions to 14 lions, you don't get 16 mega lions, super lions, right? They don't change. It's just more of the same thing. So we don't get 16 24ths, we get 16 12ths. Okay? The denominators must be the same and they stay the same. If you are thinking in your head right now, do I need to simplify? That's like asking your lit teacher, so I know you assigned this essay for us to write. Do you want me to end my sentences with punctuation, periods, question marks? Is that what you're looking for? Yes. Yes. If you ask me if you need to simplify, the answer is always yes. It's just what you do. Just what you do. So in this case, 16 12ths, we're going to take that, we're going to divide by the greatest common factor, which in this case is 4. So 16 divided by 4 is 4, 12 divided by 4 is 3. And so 4/3 would be our final answer. If you'd like to convert to a mixed number, that is okay. I will tell you, though, as you get deeper into the maths, we will use improper fractions more and more, and mixed numbers less and less. So either answer is fine because they're equivalent values in simplest form, but just be aware that we will start to use improper fractions more. Okay? All right. Crash course. Good review. Any questions, issues that you have with anything that I said? No. Okay. If you come across a mixed number in the expression, my recommendation is to convert it to an improper fraction and then go ahead with your addition or subtraction. So 1 3/4 will become 7/4 and then minus 6/7. What would 2 5/9 be as an improper fraction? And if you answer this, be prepared to tell me why you got the answer you got. Yeah? 23/9. And how'd you get that? Okay, so the shortcut here to convert a mixed number to an improper fraction is to multiply the denominator by the whole. 9 times 2 is 18, and then add the numerator, and that's how we get 23. Mathematically, why does that shortcut work? I want to dig a little bit deeper than just why does that work, Erica?
Because you have to have 9 9 to have a whole, so then 2 wholes times 9 and plus 5.
Fantastic. Excellent. Yes. Having 2 wholes here represents 2 wholes of 9/9, right? How many ninths make 1 whole? None of them do. So really, we've got 1 whole, 9/9, plus our second whole, which is another 9/9, plus the part we have of 5/9. And when we add those fractions together, 9 plus 9 plus 5 is 23, and of course our denominator stays the same, and we get that 23/9. Great. Using the shortcut is, why wouldn't you use it? But I'm also very pleased to hear that you know why it works. That's important too. Okay. Some things you don't need to know why they work. I don't know why when I dial a number on my phone, someone else answers. I don't know how that works. I don't get it, but I don't really need to know that. But here, it's important to know why that works mathematically. Okay. If there are no other questions, comments, concerns, complaints, comments, congratulations, or criticisms, I'll just let you work on the work, and that'll be that. Yes?
How do you want us to show our work for this part?
For the integer section, as far as showing work, does it say to show your work on there? I don't think it. Yeah. There's not really a whole lot of work to be shown. It may help you, and I'm going to delete this, so if anybody needs these notes, put your hand up so I can, okay. It may help you on that section. You just want to see me scroll back up to the top, don't you? And struggle with this. Okay. It may help you to, rewrite this as -4 plus 5. If you want to do that, that'd be fun. Or 14 minus 3 there. Or maybe you want to write above the operation which direction you're going on the number line. Anything that'll help you kind of just not make those mistakes. But as far as work to be shown, there's not a whole lot. Okay. With the decimals, though, I do want to see them lined up. And then with the fractions, of course, the whole denominator process is important. Question, yes? Ask it again. On the decimal and fraction section, I need to see that you show me evidence you didn't just put it into a calculator. So at least line them up, and if you want to add or subtract in your head, then that is okay. Yes?
For the fraction section, is it okay if we don't put stuff as mixed numbers and keep them as improper fractions?
Yes, as long as they're in simplest form. Improper fraction or mixed numbers are fine. Okay, that is how you math.